Yeah, I zoomed in a little bit, but it makes my hands look really huge. But I just want you to know I zoomed in. I don't have enormously big hands. I think my hands are proportional to my body. I'm not sure. But I don't know why I just said that. When I showed you this formula before, the AT was first, the U was second. I just want you to know I noticed that it's normally written this way in the Cambridge textbook that I'm using. I'm using a very old version, but I assume that it's the same and they haven't changed it. It's just a convention that Cambridge uses, so I'll stick with this so nobody gets confused. Anyway, we want a formula. We want to eliminate t. We want a formula where we don't have to use t because we're not given it and we have to use the other variables to solve for whatever we're solving for. So what we're going to do is we're going to rearrange these. We're going to isolate t on both of these over, so 2s over u plus v, Okay, so I'm going to, t is equal to t, so this is equal to this. So I'm going to set these equal to each other. Is equal to 2s over u plus v. And I'm going to cross multiply. So 2as was equal to, my God, my hands look enormous. V minus u, and I'm going to switch these around so it's easier to see. And we can see that we have a difference of squares here. So it's like if you have x plus 4, x minus 4, you just get x squared minus 16. This is the same. V squared minus u squared is equal to 2as. And one more step, and we've got our new formula. So v squared is equal to u squared, and they write the u squared first, I checked, so plus 2as. Whoops. We've got our new formula now. Okay, here's our problem, and this one's a little bit more challenging than the ones we have been doing for three reasons. One, we're using a new formula, which is a little bit more difficult. Secondly, this is in kilometers per hour, so we're going to have to convert it to meters per second. Please always remember to keep your units consistent. So if you're using meters for distance, use meters for speed as well. It makes it so much easier. And what's the third? The third reason is because he decelerates this time, so this is going to be a negative acceleration. So please pause the video. I'm not going to read it to you. I'm pretty sure you all know how to read. So go ahead and pause the video, read the problem, and try to solve it on your own. Let's think about this problem. So it's traveling 96 kilometers per hour, and we're trying to find out if it stops in time, if it stops completely before hitting the dog. So what's our final v going to be? So our final v is going to be 0. 0 meters per second. Now we're stuck in kilometers per hour so far, but we're going to fix that right now for u, for our initial acceleration. So we're just going to convert it. So we're going to do, for 1 kilometer, we've got 1,000 meters. Whoops, I need one more 0 there. Darn it, I don't like how that looks, but. And now we're going to do 3,600 seconds for 1 hour. And always make sure your units cancel and see what you're left with. So we're left with meters per second, so now we just have to do a little bit of math to determine what our quantity is in meters per second. Okay, I'm going to simplify this. I don't want to work with such a big number, so I'm going to take away 2 zeros, and I've got 960 over 36. So for you, I'm going to use 80 over 3 meters per second. There we go. For S, the question is, does he stop in time? So S is what we're looking for. No, sorry. S is distance. And don't forget your acceleration is a negative. So now we're going to use this new formula that we just learned, which is v squared is equal to u squared plus 2as. And we're hoping, because we're all dog lovers, we're hoping that S is less than 100 meters. So, because the suspense built a little bit, I can't take it much longer. I have to solve it to find out if this dog is still alive. Okay, so U, we've got 80/3. So I'm just going to go ahead and call it 6,000. I'm going to go ahead and square it, which is probably not good because you're just beginning to learn this. But what I did was I put 80/3, and I just went ahead and squared it and skipped that step because I'm really anxious to find out if this dog is going to be safe. So 2 times acceleration, which is negative 0.4, so negative 0.4, and S. And I'm going to put in 0 for v squared. So it's just going to be set to 0. We subtracted the 6,409, and I changed 0.8 to negative 4/5, negative 0.8 to negative 4/5. I just changed it from a decimal to a fraction. Okay, I didn't intend for this to happen, but there's bad news, but there will be a happy ending, okay? So it takes the car 888.9 meters to stop. So the dog got pretty hard. But I am going to change the ending because I adapted this problem from another one that I found. And